Hello friends, welcome to my channel. So as we studied effects and types of force in the last video, in this video we would be covering introduction to pressure, how pressure gets affected by force and area, and measuring pressure, how pressure is exerted by liquids and gases, atmospheric pressure, Madgeburg Hemispheres, and applications of pressures. So first of all, sorry that I was on a long break for Chhat and Diwali. So really sorry from the core of my heart. So let us begin. First of all, we would learn about what is pressure. So when force acts on an object, it is called pressure. As shown in the picture, a man's force is acting on the object and the object is lifted in the air. So the man is applying pressure on the planks. This is clear to everyone, and if it's not clear, then please mention me in the comment section. So let us shift to our next topic, that how pressure is affected by force in area. I have divided that into two parts, that how pressure is affected by force and how pressure is affected by area. So let us study them one by one. First, how pressure is affected by force. Pressure is affected by force. This can be proved by giving the example of horse which pulls a heavy cart due to its muscular force, whereas the same cart cannot be pulled by a man due to less force applied. I am trying to say in the example that the horse has much muscles in its body, and by its muscular force that we have studied in the last video, horse pulls the cart and applies force. As force is acting on the car, the horse is applying pressure on the cart. So horse is applying pressure. The pressure that is applied by the horse, this pressure cannot be applied by a human, because horse applies a huge pressure that is measured in horsepowers. So horse applies more force, that is why it's converted into more pressure. So let us further go on how pressure is affected by area. How is pressure affected by area? Force is affected by area. This can be proved. By the example that when we apply pressure on the wall by a thing that has a big area, wall hardly gets affected. Whereas when a screw with the small tip gives same pressure on the wall always gets affected. First of all, sorry guys that I gave a mistake in this PPT presentation, that I had to write here pressure, but I wrote force. So please don't mention in your notes which you are noting. So let us change this to pressure. So I am trying to say in this example that whenever we hit a wall by a thing that has a huge area, like if I hit the wall with my thumb, then the wall gets hardly affected. I hit my thumb to the wall by a huge pressure, then also the wall gets hardly affected. But with a low pressure only, if I attack on the wall with a screwdriver, then the screwdriver gets inserted in the wall. That comes to a use of hanging things. So you must be thinking that why does the screwdriver goes in easily and our thumb doesn't go easily? So the basic answer is that screwdriver's area is very much less, and our thumb's area is huge compared to the area of tip of the screwdriver. So in next slide we would study that how do we measure pressure, in that force by area is the measure of pressure. So as area got less, so pressure got less, as pressure is directly proportional to area. So let us move to our next slide. Measuring pressure. Pressure equal to force by area. As I said in the last slide, that pressure equals to force by area. So why pressure equal to force by area? As we studied in the last two slides, that pressure is affected by both force and area. So pressure is affected by force and area, and that is why pressure equal to force by area. Next, we study that the standard unit of pressure is pascals. So every unit that is measured in science or maths has a standard unit. The unit that is commonly used in that thing, like the standard unit of force are Newton that we studied in the last video, and the standard unit of pressure is Pascal, that is also denoted by PA. See, every standard unit have a short form so that we can use them in the numericals. Uh, like the short form of Newton is N, and that only, and like that only, the short form of Pascal is PA. So 1 kilopascal is equals to 1000 Pascal. So this is only the reason that is. So you must be thinking that why do we write kilopascal, millipascal like that? We can also write directly 1000 Pascal in the numericals. So that is wrong, because in the numericals they are huge, and their division is and and their operation is very difficult. So to make them easy, people added a term kilopascal that is equal to 1000 pascals. So this slide is fully clear to you all, as I expect. So let us move to our next slide. Pressure exerted by liquids. In the beginning of video only, I said that we would discuss that how pressure is affected by gases and liquids. So in the next slide we will study that how pressure would be affected by the gases but in this slide we would study that how pressure is exerted by liquids. So firstly, everything in this world present exerts pressure on anything. Like you are sitting on a chair, so the chair is exerting pressure on the ground. So like you are drinking water, the water like you are drinking the water present in the glass is exerting pressure to the glass. The water present in the dams is exerting pressure to the dams. Everything is exerting pressure, but what is different is that three matters, solid, liquid and gas, exert pressure in different way. Firstly, we would study liquids. Liquids exert pressure to the bottom of their container. Yeah, liquids, the pressure that is exerted by the liquids get increased by the bottom. This can be proved by an example that you take a bottle and in the bottle you make 3 holes. So the most and you open, after making the 3 holes, you open the cap of the bottle. First jet will go like this, second jet will go like this, and the third jet will go like this. This is because the pressure is exerted most to the bottom and least to the top surface of the liquid. The pressure is made between the middle area of a liquid. This is because the pressure is exerted on this least. On this area, the pressure of the top, the upper area of the glass, and all the water above it is is in the pressure. So the bottom will have most pressure. That is why we can also say that the liquids exert pressure to the bottom of the container, or liquids the pressure exerted by the liquids is directly proportional to the increasing depth of the container. So in dams, I here pasted a picture of a dam. So in dams, basically what happens, that water gives on pressure to the bottom of the dam, and and water is in huge amount. That is why the pressure exerted on the dam is also in huge amount. That is why it is necessary to give the walls of the dam of thick layers. Like in the glass we can see that this area is very thick. This is because liquid exert pressure here at the most, and if it is not strong, then liquid will break the glass by its pressure. Like in the dams, if the walls are not strong, then liquid is in huge amount and can break it. So I expect that the pressure exerted by liquid is cleared by everyone. So we should further go on the next topic, pressure exerted by gases. Gases also exert pressure. Their pressure exerted is directly proportional to the amount. I here mistook to add the amount of gas. So that is why the container of the cylinders are very thick. This is only because as gases in the cylinder are in a huge amount and they exert much pressure on the cylinder, this pressure is also in a huge amount. So as like always, if the walls of the cylinder would be not thick and very thin, then the gases would basically go and make a hole in the cylinder, and all gases will escape through this. That is why a pressure cooker is made of steel or iron, but not plastic. So I expect the pressure that is exerted by the gases are also clear. So let us move to the next topic, atmospheric pressure. Pressure that is exerted by the gases on the atmosphere is called atmospheric pressure. So in the last slide, we studied that the gases exert pressure on their container. So atmosphere is a huge container of gases. All the gases that random here and there, they have no use and random in the they have no use, and they go here and there in the atmosphere. So atmosphere is the container of the gases. That is why gases also exert pressure on the atmosphere. That pressure only is known as the atmospheric pressure. So that is clear, I expect. So now a term is very drastic and very heavy that many children do not understand. So I will try my best to understand you all these terms. Firstly is that atmospheric pressure is highest above the sea level. So firstly, why is atmospheric pressure highest above the sea level? I have also been thinking this question for many days, and finally I took its answer. So basically, pressure is highest above sea level because it has the greatest depth. So gets the greatest pressure. As I said you that, see, let us expect that this is the atmospheric pressure. So the pressure in the sea is the highest. We studied that if in that on anything, if we give pressure, then it gives us opposite and equal pressure. That is the law of motion, that is the law of Newton, that we would study in class 9th. So as the depth increases and the depth of the sea is greatest, so sea exerts pressure back to the greatest. That is why atmosphere gets pressure from the gases and extra pressure from the sea. So atmospheric pressure is highest above the sea level. Now you all must be thinking that if atmospheric pressure is so much that it can crush anything, then why are we not crushed yet by atmospheric pressure? The answer is basically simple, that our blood pressure that always goes in our body. I can make a brief video on it too if you all request in comment section, so comment down below. So the blood pressure that all the time gets the blood pressure that all the time pressures our body is little more than the atmospheric pressure, so they get balanced. So let us move to the next topic, Madgeburg Hemispheres. This is also a very much troubling topic, so let us see this. Madgeburg hemispheres are the working examples of air goes from high pressure to low pressure. Yeah, so many people wouldn't have understood Madgeburg hemispheres yet, so I make you understand. See, uh, this is the hole in the Madgeburg hemisphere. Here a pipe is attached, and through that pipe a vacuum is attached. The vacuum sucks all the air inside the Madgeburg hemispheres. Now, as it sucked all the air and closed this container, now there is no air inside. There is a low pressure inside, and there is a high pressure in atmosphere. So the pressure will go from all sides to fill that low pressure. All the high pressure will go from all sides to fill that low pressure. That is why, and there is a solid between them, so they cannot reach the low pressure and give their highest pressure to reach that. So even if we attach 10 horses to this side and 10 horses to this side and let them pull this Madgeburg hemispheres, then also it does not get separated. So so this is the working example of air goes from high pressure to low pressure. So the next and the last topic are about some applications of atmospheric pressure. So first, drinking straw. Now, in the last thing I said about how Madgeburg hemisphere works, same works with it. Now see, we insert the drinking straw inside a drink and we suck the liquid, and the liquid comes in our mouth. Why? Because as we suck the air inside, it becomes a low pressure inside the straw, and as it becomes the low pressure, the air from all the sides goes to fill the low pressure, but there's a liquid in between, so they give huge pressure on the liquid, and the liquid goes up through the hole that is in the straw. This is only how syringe works. This is only how dropper works, but rubber works in a different way. See, this rubber cleaner that cleans most of our toilets is basically an example of the last one, that that air goes from high pressure to low pressure. So see, as we pressed it to the ground, all the air from it escaped, so there's a low pressure inside. So again the air of all sides will come to fill it, and it gets attached to the ground. And but if we pull it with a huge pressure, then it comes up. So thank you guys, that was only my video for today, and I expect that आप लोगों को सब चीज़ें समझ में आ चुकी होंगी. If you don't get them right, then comment me down in the comment section. And so thanks for watching. Please subscribe my channel, Learn with Fun.